boys and girls. This is Mrs. Lauren again, and today we're doing Unit 6, Lesson 2, Powers of 10. We're going to use exponents to show powers of 10. So in my classes, we've been talking a lot about order of operations, and so when we do order of operations, we use the acronym PEMDAS, right? So remember, we start with parentheses, then we do exponents, multiplication and division in order from left to right, and addition and subtraction in order from left to right. So now we're going to find out what those exponents mean. What is that? How many do you see and how do you see them? What's a good estimate for the number of smallest line segments you can see? And how can you find out exactly how many there are? Well, the first thing I notice is that there are, let's see, let me get my pen out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 of these little things on the pinwheels, right? They have long spokes. These are our spokes. And then it's either, I don't know, do you see snowflakes? I don't know what they're called. But I see 10 of those, right? And then each one of those 10 has 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I imagine if I could blow this up, this little picture, that each one of those would have 10. So far I have 10, and then each 10 has 10. So, right? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So I see 10 and then 100, and then I see, I don't know, let's see, at the end of the little spokes, each one of those has 10, so that's 10 times 10, which is 10 times 10, which is 100. So if each one of these has 100 in them now, right? We said that this had 100, 100, 100, and 100, right? And we went all the way around. That would be 1,000 little spokes and 10 little snowflakes on each. So that would be 10,000. That would be really hard. So I don't know, 10,000? What do y'all think? I think if we did 1,000, right? So there are 10 big ones, and then each 10 had a 10, and then each of those 10 had another 10. So 10 times 10 times 10, we can do those base numbers. 1 times 1 times 1 is 1, and then add 3 zeros. Yeah, I think 1,000. I think 1,000. How can we find out what it would be exactly? I can multiply. I can count the number of long segments, and then the number of medium-sized segments, and then the long one, and then the little tiny, teeny tinies, and I can multiply those. So that's, I think, what I did here. How does this expression relate to the diagram? Let's see, I think that's on the next page. Yeah. So I have 10 big ones, right? 10 of these. And then I have 10 of these. 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then each one has 10 on it. So 1,000. Another way to write 10 times 10 times 10 is 10 to the third. That's another way of writing that expression. We call this a power of 10. Okay, 10 to the third is a power of 10. The number 3, and we write that number 3 tiny. So when we write it, let's see if they wrote it for you. Yeah, they write it up at the end of the number and very tiny. And that tells us how many times we multiply 10 by itself. It's always tens, right? 10 times 10 times 10. This number tells me how many times to multiply it. Okay. There are 1 million people living in Delaware. How do we say this number? Well, I just read it to you so you know. We say 1 million. That's how we say it. Or we could write the number 1. 1 like that. 1 million. That's a lot of people, right? 1 million. How many thousands is this? How many thousands is that? That's a good question. So to be able to tell me how many thousands that was, I would have to divide 1 million divided by 1,000. Or I could say 1,000 times what would give me a million. So what am I going to have to multiply to get 3 more zeros? How many more am I going to multiply by? I think if I have 3 zeros here and I need 6 zeros at the end, I'm going to multiply by 1,000. So I think there are 1,000 thousands is a million. Write the number using the power of 10. Well, remember before in that first exercise, if we did 10 times 10 times 10, that was 1,000. And we could write that, equals 10 to the third, right? Because it had 3 zeros and we multiplied it 3 times. Well, how many times do we have to multiply 10 to get 6 zeros? Well, if we had to multiply 10 3 times to get 3 zeros, I imagine we would have to multiply 10 6 times to get 6 zeros. So I think that would equal 1 million. Okay? How many times would you need to extend the diagram from the warm-up to get a million tiny segments? Well, remember we decided that the warm-up there were 1,000. So how many more times would we have to extend it to get a million? I need 3 more zeros. So I think we would have to extend it 3 more times. Because each time we are adding 10 more, right? 10 more. So we would need 3 more times to extend that. All right, that's some good thinking there. Number 2, in 1997, the population of India was about, that number we say, how do we say that? 1 billion. Because there's 3, 6, 9 zeros in that, right? These are the thousands, these are the millions, and I have one more than that, so that's a billion. How many millions is that? How many millions is that? I think it's 1,000 million. So how many millions is that? What do I multiply 1 million by times what is going to give me 1 billion? How many more zeros do I need? This has 6 zeros and this has 9 zeros. I need 3 more zeros. So I'm going to multiply that by 1,000 because it has 3 zeros. So 1,000 millions would make a billion. How many thousands is it? So now I'm going to ask myself, what do I have to multiply 1,000 by to get to a billion? Oh my goodness. Well, 1,000 only has 3 zeros. So I'm going to have to multiply it by a million. 1, 2, 3, 4, 5, 6, 7, 8, 9. So now I get my 9 zeros. Now we have to write that using a power of 10. Well, how many zeros does it have? It has 9 zeros. So that means I'm going to have to multiply 10 9 times, right? 3, 4, 5, 6, 7, 8, 9. I'd much rather write 10 to the 9th power than to write this equation or to write this number actually. So remember, when we're multiplying these numbers by powers of 10, we multiply the base number times itself. Well, 1 times anything is 1, right? 1 times however many ones you have is going to be 1. And then I count the zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. 3, 6, 9. How many times would you need to extend the diagram to get from the warm-up to get 1 billion tiny segments? That's a good question. How many times would I have to extend it? Well, I would think if I had to extend it 3 more times to get a million, I need a billion. I think I'm going to have to do twice that much and do 6 more times. Why do I think that? Because 3 more than, right, 10 to the 6th. Remember, a million was 10 to the 6th, and I need to get 10 to the 9th. Ten to the 9th, which would mean adding 3 more zeros at the end of the number. All right, let's move on from there. That was kind of hard. How do we say this number? We say 1 billion. How many millions are there in this number? 1,000, because there are 3 more zeros, and that means multiplying by 10 3 times. How do you write this number using a power of 10? Well, how many zeros are in there, right? What am I going to multiply 10 by? How many times am I going to multiply 10? So it's going to be 10 to the 9th because there are 9 zeros and 9 factors of 10. This number is called a billion. Using powers of 10, can you write a number that's bigger than a billion? Yeah, easily. If I don't have to write all those zeros, I can write, 10 to the 10th, or 10 to the 11th, or 10 to the 200th, right? Those are all bigger numbers. Why are powers of 10 useful for representing really big numbers? I don't know about you, but I don't want to write 100 zeros or 200 zeros right here. Let's go back one. Sorry about that. There we are. I don't want to write that many zeros. I don't even want to write 9 zeros, but I certainly don't want to write 11 or 200 zeros. And I would have to count all those zeros to see how big that number is. So using powers of 10 helps me to write big, big, big numbers. All right. Now, next activity, powers of 10. Find the missing number that makes each a statement true. Show your reasoning. So what do I have to multiply this 20 by to get 2,000? Well, I already have 1 0, and I know 2 times 1 is 2. I need 2 more zeros, right? So I'm going to multiply it times 100. So then when I multiply, I know 2 times 1 is 2, and then I have 1, 2, 3 zeros. 1, 2, 3 zeros. Okay, here's one. 20 times 10, I know that's going to be 2 with 2 zeros, times what will give me 20,000? Well, I need 4 zeros. 1, 2, 3, 4 zeros. So I'm going to have to multiply this times something that will give me 2 more zeros. So I'm going to multiply it times 100. What times 10 is 100,000? Well, here's 1 0, and I need 1, 2, 3, 4, 5 zeros. So I'm going to have to multiply it. I have 1 already taken care of, so I need to multiply it by 1, 2, 3, and there's my 4th zero. Multiplying by tens, or powers of 10, is really easy, isn't it? 1 times 1 is 1, and then I have 3 zeros here. 1, 2, 3. And I have 1, 2, 3, 4 there. 1, 2, 3, 4. And then I'm going to block them off in 3, so that's 10 million. How are the products of tens useful in solving these problems? It was super easy, wasn't it? It was super easy because all I had to do was count those zeros. I can solve each of the problems by taking the successive products of 10 and keeping track of how many factors of 10 I needed. That's all I needed to do, right? I needed to just count zeros. I need 3 zeros, so here's 1, 2, 3. I need 4 zeros, here's 1, 2, 3, 4. I needed 5 zeros, 1, 2, 3, 4, 5. 1, 2, 3, 4. Uh-oh, I did not do that one correctly, did I? Let's do that one again. Good thing I was checking. 1, 2, 3, 4, 5. I have 1, so I'm going to need 4 zeros. There we go. Let's make sure I did this one right. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Very good. All right. Write each power of 10 as a number. Well, remember that this is going to be 10 times 10 times 10, or a 1 and 3 zeros. Same thing for this one. It's going to be a 1 and 4 zeros. And this is going to be a 1 and 7 zeros. 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. All right. Let's see what they ask us about this page. How did you find the number that makes blank times 10, 100,000 true? Okay. Well, I started with 1,000 times 10, and that's 10,000, and I knew I needed another factor of 10. I also just thought about the zeros again, right? What times 10 would give me this many zeros? So if I started with 1,000, that would be 2, 3, 4 zeros. Is that enough? 1, 2, 3, 4, 5. No, I need 5 zeros. So I'm going to add a zero. 1, 2, I have one already. I need 1, 2, 3, 4. 1, 2, 3, 4. So 1, 2, 3, 4 times 10 would be 1, 2, 3, 4, 5, which is 100,000. Did thinking about the factors of 10 help solve this equation? Absolutely. Absolutely helped me solve that equation. I had to know how many zeros needed to be in the problem, right? I started with 1,000, and 10 times that is 10,000, and I knew I needed another factor of 10 to get that. What is the value of 1,000 times 10,000? Well, I know that I have 1, 2, 3, 4, 5, 6, 7 zeros, and it's 1 times 1 is 1, so it's going to be 7 zeros. 1, 2, 3, 4, 5, 6, and there's my seventh one. How did I find that value? Well, I thought about the factors. I thought about the factors of 10, and I know that when I multiply my base number times my base number, the zeros are just factors of 10, right? I can just add those zeros. How do I say this number? 10 to the third power, or equals 1,000. 10 to the fourth power equals 10,000. 10 to the seventh power equals 10 million. Well, I think they're asking me, how do I say that number? This is 10 million, right? What do you notice about these equations? I notice that the power, right? The power is the same number of zeros. The power has the same number of zeros. The power has the same number of zeros. That's what I notice. The number of zeros on each of the numbers is the same as the power. All right, we're going to investigate a big number. What's the biggest number you can think of? And how do you say it? How do you write it in number form? You can ask your friends those numbers and share for a little bit, and we'll move on to the next activity. How would you say this number? So I know that these are the hundreds, thousands, millions, billions. How would you say that? 1,000 billions? A million millions? We could also say a trillion. How many billions is that? How many billions is this number? Well, it's going to be 1,000 billions. 1,000 billions. So if it's millions, it's going to be a million millions. Right? Because there are 3 more zeros, it's a million millions. 3 more zeros in this one. This one only has 6 zeros. This one has double it, right? There we go. Write the number using a power of 10. All right, so we're going to use 10, and then how many zeros are there? 3, 6, 9, 12. So we're going to say 10 to the 12th power. Describe an example of something that there would be a trillion of in the world. Let's see, I could think of grains of sand, maybe stars, blades of grass. I'd have to really think about that to get some more. Um, Maybe the number of plants on Earth. Would you think maybe the number of animals? I don't know if it would be the number of animals. It's a lot. That's a lot. All right, let's see what's next. What are some things that there may be a trillion of in the world? How did you choose? Why is it so hard to guess whether there are a trillion of something like grains of sand? It's too big a number to count, right? So we would never sit there and count the grains of sand. It'd be really, really big. All right. Today we looked at some really big numbers that are powers of 10 and represented them using exponents. How many of the medium-sized segments are there? Well, remember we said that there were 100. So these 10, 10 times, 10, 10, 10, 10, 10, and 10, and 10, and 10. And we know that 10, 10 times is 100. So there are 100. How does the image represent the expression 10 times 10? Well, exactly. There are 10 groups of these segments and 10 segments in each group. We can also represent this expression with a power of 10. 10 squared, right? All right. What expression could you write to represent the small number of segments? Well, I know that if this is 10, get this right here. This is 10, and each one of those has 10. So that's 10 times 10. And then there are 10 of them. So each one of these is 10. There are 10 of them. And then each one of these is 10. We know that that's 1,000. Or we could write 10 to the third. What power of 10 can you write? We wrote that, 10 to the third. If you keep going and drew 10 more tiny segments, how many of those would there be? Well, if I did another 10, right? So 10 times 10 times 10. If I kept going, then I would do another 10, and we could write 10 to the fourth. Wrote that. If I kept going a total of 6 times, how many of the smallest segments would there be? So that would be 6 times would be 1, 2, 3, 4, 5, 6, right? So we would do 10 times 10, 6 times. 2, 3, 4, 5, and here's 6, which would be 1,000,000 or 10 to the 6th. So we could write that as a power as well, couldn't we? All right, here's our cool down. Write 10,000 and 100,000 using exponential notation. So those are big words for just writing exponents, exponents, right? So 10,000, 10,000, how many zeros is that? 1, 2, 3, 4. So we would have to write 10 times 10 times 10 times 10 4 times. So that means it's going to be 10 to the 4th. Then here we go, 100,000. How many zeros do I have? 5. So that one's going to be 10 to the 5th. Then we want to write 10 to the 6th as a number. Same thing. We're going to write 1 with 6 zeros. 4, 5, 6. So that's 1,000,000, isn't it? All right. Good job, boys and girls. I hope that you enjoyed Powers of 10. It's one of my most favorite things to do because it is so easy, right? It's counting those decimal points, counting those zeros, especially when we're multiplying by tens. Super fun. All right, I hope to see you next time on lesson 3. Lesson 3, we're going to start talking about, I can get my paper open, metric conversion and multiplication by powers of 10. The metric system uses powers of 10 all the time, and it makes measurement so much easier when we use the metric system. I hope to see you in lesson 3. Please like and subscribe.